The broadcast is now starting. All attendees are in listen-only mode.
Hello, welcome everyone. Today is going to be the July California-Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thanks for those that are joining us today and those that are joining us again. We've got a great following with these webinars and we're hoping to keep it going today. My name is Amanda Sheffield and I am the Regional Drought Information Coordinator for NIDIS for California, Nevada, and I sit at Scripps Institution of Oceanography in San Diego. This bi-monthly webinar series is designed to provide the region with timely information on the current drought status, its associated impacts, as well as a preview of upcoming climatic events. This webinar is being recorded. The recording, along with a two-page summary, will be available later this week on drought.gov, and the recording will actually be up even faster, likely tomorrow, on our YouTube channel, which I'll show the link at the end. So before we get started, just a little briefer on NIDIS again. So NIDIS is the National Integrated Drought Information System. We work to provide a better understanding of how and why drought affects society, the economy, and the environment. And in working towards an integrated system, we try to make sure people have access and use of early warning information for drought risk management. As we work towards a national drought early warning system, we do this by building off a network of regional drought early warning systems. So what is a drought early warning system? They are basically new and existing partner networks that work together between the federal, tribal, state, local, and academic partners to make sure we have climate and drought science information and impact information ready, available, easily understandable, and usable for decision makers. And in California, Nevada, that includes many different partners and work going on. We've highlighted them in a strategic plan, as well as we have quarterly key stakeholder calls to talk about current conditions and also activities that are going on. If you're interested in becoming more involved with the drought early warning system, feel free to contact me and I'll have my information at the end. And then back to the webinar. So today we've got a setup of the Drought and Climate Update by Dave Sumrall. He's with the Western Regional Climate Center. I will be giving the Drought and Climate Outlook. We then have a fire conditions impacts and outlook from Ed Delgado from the National Energy and Fire Center. And then finally, talking about a project that was funded through the NOAA RESA program, Julie Clancy will be talking about work she's done with Southern Nevada Water Authority. With that, I'm going to go ahead and pass over to Dave. As I mentioned, he's an Associate Research Scientist of Climatology with the Western Regional Climate Center, and he's at the Desert Research Institute. And Dave, I'm going to pass the screen over to you.
Okay, thank you.
This is just a quick reminder, we usually do questions at the end, so I'll do small ones while we change presentations if it's needed, but otherwise we'll save most of them for the end and go ahead and type your questions into the questions box. And Dave, you're good to go.
Okay, thanks Amanda. We'll get started here. So first taking a look at the current drought status. This is the latest map that came out last week. And you can see that both California and Nevada have some drought on the map. Most of the, moderate to extreme drought is in Southern California. Central and Northern California, we've got some abnormally dry to moderate drought conditions. If you take a look at the change map in the bottom right-hand corner, you can see that's over the past 2 months what kind of changes have occurred on the Drought Monitor map. And you can see that we've introduced some D1 drought and expansion of D0 in Northern California. We're not seeing any drought impacts in basically either of the areas. We're not really seeing much in the way of impacts in California or Nevada. This is mainly meteorological drought that we're experiencing in both states. The introduction of the D1 in Northern California was in relation to some precip deficits that started in about April timeframe. This is taking a closer look at the current maps for California and Nevada. We've got about 44% of California that's in somewhere between D1 and D4. And Nevada, a little better condition, about 30%, although I expect some expansion of D1 to occur probably in the northeastern corner of the state. As I mentioned just a moment ago, we're not really seeing much in the way of drought impacts, although we're starting to see some recent reports coming in. Actually, one of these just came in today. On the left-hand side, this is sent in, this is a spring that up in northeastern part of Nevada and Elko County that's drying out. On the right side in Lincoln County, this is the Middle Pass Reservoir, and that reservoir is currently dry, and that's apparently the first time since 2000 that it's a smaller reservoir, but still experiencing some dry conditions in those areas. So looking at some of the drought indicators, these are from the objective blends these are experimental drought blends from CPC, and they combine a number of different drought indicators. They look at climate division data, a couple of the Palmer indexes, indices, and then also soil moisture and precipitation at various scales. And this is the latest map, and you can see we're seeing both long and short term, and those are, you can see in the dashes, and there's some S's and L's on there, and those are indicating that you're seeing both short and long-term indicators of drought within those climate divisions. Moving on, these are the short-term blends and long-term. The formulation for the long-term is different for the western U.S. You can see that on the right-hand side. I have an arrow pointing to it. That's essentially the different indicators that are going into that particular blend. So that's looking at indicators from 12 months out to 60 months. So you're seeing some kind of D3 conditions in the long term that are showing up in the indicators in Southern California, and some D1 and D2 level in Southern Nevada and across much of California. Short term, again, you're seeing some D3 and D2 conditions in Southern California, and D1 in central and northeastern Nevada, as well as the Central Valley and northwestern California. Give a little context, how we got to where we are now. This is looking at, this is from the ACES maps that are made by the regional climate centers. On the left-hand side, we have precipitation, percentage of average from the water year to date, and you can see we've got well below average conditions, precipitation starting at the beginning of the water year in much of California and southern Nevada. You can see there's some above average precip that's occurred in the central and parts of the northern Sierra and northwestern Nevada. That's mainly in relation to the precipitation that we received in March. And looking over on the right-hand side, we're looking at temperature departures for that same period. And we're seeing near normal to above normal temperatures for the water year. These are a couple, this is precipitation and temperature ranking maps looking at January through June. And this is from NCEI, the State of the Climate Report. This came from the last report in June. We don't have the July data yet. So looking at the left temperature, you can see that that period from January through June was well above average temperature, and statewide precip rankings are kind of near average. Looking at temperature departures since the last time there was an outlook, so it's looking at the 30 and 60 day, you can see that we've had above average temperatures looking at the 30 day across much of California and Nevada. Looking at some more of the Precip rankings, temperature rankings for the month of June, above average temperatures and below normal precipitation. The precipitation, that's no surprise since we're in dry season. I pulled a couple of some statistics off of ACES, and that's the database that's used by the regional climate centers. And we've experienced a couple of heat waves in July in both California and to a lesser extent in Nevada. There was some record-breaking heat in Southern California around the 6th and 7th of July, and we've got high pressure building again in California, and we're expecting another heat wave with some record temperatures again this week. So these tables that I've created here, and I've sorted them, it doesn't have all the counties, but these are on the left-hand side are maximum temperatures from July 1st through July 20th for Nevada, and to the right of that is California. And I've just sorted them by the maximum temperatures that were experienced in each of those counties for that time period. And then this was the July 6th heat wave, and you can see the exceptionally warm temperatures in the LA basin, where LA, in downtown LA area, we're getting over well over 100 degrees, and moving eastward in the LA basin, temperatures up to 118 degrees. As far as precipitation, again, this is dry season, although there are parts of Southern California and Nevada that do get some monsoonal moisture. And as you can see, on the left-hand side is a map of total precipitation over the last 30 days, and on the right are the departures from average. And you can see that we've had some monsoonal activity in the southeastern deserts, and as well as in southern and central Nevada, the eastern Sierra Nevada, and Mono and Inyo counties. We've had some pretty good precip, and those came from a couple events. You can see the purple, the cooler colors in southern Nevada. That's over the Spring Mountains. And there were a couple rainfall events where they, within a couple of days, had received about 4 to 5 inches of precip in those events. Taking a look at some of the other indicators of vegetation, you can see these are two different products. On the left, this is from the U.S. Forest Service. These are departures from average greenness. And on the right, this is a veg dry product from the U.S. Drought Monitor. And you can see in the darker, warmer colors, we've got quite a bit of dry vegetation in Southern California, as well as the southern half of Nevada as well. Looking at soil moisture, we have some dry spots of soil showing up in parts of southern Nevada, as well as northwestern Nevada and southern California, as well as in the northwestern part of the state, which was part of the reason, one of the factors for introducing some of the D1 and abnormally dry D0 in northwestern California. On the right, we have a couple products from the USDA, and these are from a private network that they have looking at soil moisture. And you can see California has quite a bit, about 80% of their network are showing short to very short in terms of topsoil moisture, and about 75% short to very short for subsoil moisture. And I'm not going to go too much into this because that'll be talking about the fire situation, but I just thought this was noteworthy. On the left, you can see this is a MODIS image from, I think I pulled this from last weekend. You can see the fire, smoke coming from the Ferguson fire, which is burning just to the west of Yosemite National Park. about 6% contained. And I've included an air quality map because there's quite a bit of the region on the east side of the Sierras, as well as the Sierras and western Nevada, that have been impacted by the smoke from the fire. Here's a couple screenshots I took from fire cams from the UNR seismology network, and this was on last Friday. And you can see on the left-hand side, that's an image of Reno, and we were pretty socked in with smoke from the fire. And on the right, that was the same time from Lake Tahoe. Take a look at the reservoir levels on the left-hand side. Obviously, California, pretty good shape statewide as far as reservoir levels. We had some good carryover from last year. So we're in a pretty decent March in terms of precip, which helped. Looking over at Nevada, obviously we don't have quite as much in terms of reservoir storage as California, but looking at northwestern part of the state, that is Rye Patch Reservoir, which is right up here. And they've got about 165% of average, and that's fed by the Humboldt River coming out of northeastern Nevada, so they're in pretty good shape. Looking at the Colorado River system, Lake Mead's about 37% full, and Lake Powell about 51% full, so it's a little bit down from last year in terms of storage throughout the system. And taking a look at current ENSO conditions from CPC, we're currently in neutral conditions at present. We've got some near to above average sea surface temperature anomalies across the Pacific, with the exception of along the South American coast, where we have some below normal temperatures. And it's looking like we've got pretty good model agreement, as you can see on the plot on the right-hand side, that most of the models are showing that we're going to go into El Nino conditions, about 65% chance during the fall, and it's looking like about a 70% chance moving into the winter of weak El Nino conditions. And Amanda's going to touch upon the outlooks, so I'll let her elaborate more on that. And finally, looking at the seasonal drought outlook, as you can see, we're expected to have drought persisting in Southern California and Northern California as well. We're going to see some improvement likely in eastern parts of Nevada, and moving a little more into the eastward in the desert Southwest. We're going to see some improvement, and that's probably in relation to the outlook showing that we're going to go into El Nino into the winter, so we might get above average precipitation in the southwestern U.S. and potentially parts of of Southern California as well. And that's about it. Thank you.
Great. Thanks, Dave. While I'm changing presentations real quick, there was a question of, do you have stats on how many places around California had all-time record highs versus just daily records during the recent heat waves? Or where to find that information, maybe?
Yeah, you could find that through the SC ACES or I believe the SC ACES data set. If the person who's asking the question wants to send me an email or give me a call, I'd be glad to help them find those numbers.
Yep. Great. Thanks, Dave. Oops. Yep. As Dave mentioned, so he gave you a little preview of the outlook that's coming up. Sorry about that. The phone went off. So I'm going to give you a little more detail. Just a reminder, though, it's very early, and this is the information that we do have, but use it with caution. and we'll start to look at why we are maybe hinting to what the forecasts are saying for El Nino for fall. Just look back again at a little bit where we are coming from. So this is a table looking back at past El Nino and La Niña events. I've highlighted in the box the more recent years where we swung from El Nino to the stronger El Nino, then to the La Niña phases in the last year, the back-to-back La Niña phases actually. And where we were coming in this spring into summer was transitioning from this cooler phase to this more neutral phase so far. And so here's a couple temperatures of ocean sea surface temperatures. Here on the right is from the last 4 weeks. Here is South America, Central America, where we're looking at these bright reds and oranges where we are warming up in the last 4 weeks and near to above average temperatures across this part of the Pacific Ocean, which is our El Nino region. And here on the left is a little more complicated figure where basically think about how you're working through time on here across this same part of the Pacific, so all the way from South America over to the Western Pacific, where in the last month or so we've been getting more of these reddish colors and yellow colors here, where before we were these bluer, cooler colors last winter. So basically, we were moving from a below average sea surface temperature time period into more of a neutral time period, and now we're hinting at a near to above average at the sea surface temperature, at least. And just to elaborate a little more on that is we basically need the entire atmosphere to trigger into an El Nino event. And so right now we're just seeing the patterns in sea surface temperatures. We're not quite seeing it in the other factors such as the convection in the Western Pacific and things like that. So basically the entire ocean atmosphere system right now is still acting more ENSO neutral-like, but sea surface temperatures are warming. Then to look more forward-looking, as Dave mentioned, right now we're in ENSO neutral, which is forecasted to last through the summer, with El Nino favored and for the fall, August to October. Here we have a bunch of different dynamical and statistical models where this more reddish area shows when they cross that barrier into El Nino zone into the fall area. While not all the models show that, there's quite a few of them that do, and we'll know more details as we get closer into the August-September timeframe of how the winter and whether it ends up being El Nino or stays closer to neutral. Right now, if you look at more, what are the odds of whether this El Nino versus neutral will occur? These are these same seasonal time periods, so July, August, September, or June, July, August, September, etc. here into this fall, early winter time period, where the red bars are El Nino, and that's where Dave was getting some of the in September, October, November, there's about a 65% chance that El Nino will occur. Neutral also is still possible. It just has lower odds of 33% and very low odds of La Nina occurring. This forecast is based on models and the forecaster consensus, so there is a human factor here looking at how the atmosphere is responding currently to the warming of SSTs. Before I go on to then what does this mean for temperature and precipitation forecasts, overall this is from the National Weather Service and Climate Prediction Center. We are in an El Nino watch. Currently we have ENSO neutral conditions, but the near to above average sea surface temperatures are what's linking to the potential for El Nino. If you want to read more about the discussions here I've listed, and I can send these later, is the CPC ENSO diagnostics discussion and also the ENSO blog, which is a more general public-friendly blog that discusses what the current conditions are like. So what does this mean for temperature and precipitation? ENSO is obviously one part of, say, the forecasting toolbox that we have, but it does play a major part. On the next few slides, I'm going to go through the temperature and precipitation outlooks from CPC, and I thought this was a good time to just give a little reminder to what these forecasts actually mean and how to interpret them. So these are the seasonal forecasts. So this one's, for example, is from August, September, October. It was made July 19th from the Climate Prediction Center. And the colors basically are highlighting which is the most likely, the higher probability category of above normal or below normal conditions. So here we're showing temperatures, and for example here in Reno, while it is orange here and about a 53% chance of above normal temperatures, There is still a chance for normal or below temperature or below normal temperatures. It's just the favored category is above. So for example, Reno here, it's 53%, and in Los Angeles, it's about 47%. I recommend, while this is more of the static image, there is this on the CPC website, a interactive version for this. This is where you can get more of these detailed pie graphs and know how the breakdown is for all the different odds of above, below, and normal. And they also tell you what the normal, maximum, and minimum temperatures are for those regions. And these are just the odds of being above or below normal. They don't tell you how much above or below normal they will be. So just a general reminder about that. Here's the same figure that you're looking at, and now I'm going to step through a couple of seasons as we go through the fall. We are looking at higher temperatures forecasted or favored through August, September, October, and continuing all the way through the rest of the fall, September, October, November, December as well. And if we look at similar graphics for precipitation, right now we are in the eastern part of the region, have slightly favored for above normal precipitation. I think if I read the discussion from CPC correctly, some of this is due to they think the monsoon is going to be a little bit better in this time period, and that pattern continues at least through the early parts of the fall. Although this far out gets a little bit harder to know how much forecast scale that we have. And then Dave showed this. This is the current drought outlook for July through October. It was released on July 19th. Right now, as we're in our dry season, California, Nevada, they don't tend to change too much of the drought outlook here. But in this eastern region, these likely to drought remains but improves or drought removal likely is a signature they're reading in from potentially the monsoon being a good monsoon time period right here. And that's all I have. So I just want to, in a summary, we have a chance of El Nino conditions for this fall, but right now the ocean atmosphere system is reflecting ENSO neutral conditions. The forecaster consensus combined with models are looking at a 65% chance of El Nino this fall and 70% chance deeper into the winter. And just a reminder that ENSO, as we've experienced the last few years, is just one part of the seasonal forecast toolbox, and we'll have to wait and see how the season develops. We're looking at for later webinars in the series to include some of those other pieces in the toolbox, including new research and things like that of other climate forcings and factors that are out there. And we're forecasted to have above normal temperatures through the fall and then equal chances to above normal in that western portion, the eastern portion of the region for above normal. And keep engaged with your local weather service offices as well as us at NIDIS, the Climate Prediction Center, and other partner programs as we keep an eye on this as we go through the fall. So with that, I don't see any questions. So I'm going to go ahead and then hop over to the next presentations, which will actually be an outlook of the fire conditions from Ed Delgado. And Ed, I'm going to pass over control over to you.
Okay. All right, can you see my screen?
Yep, you're good to go.
Okay, so good afternoon or morning, everybody. Let me quickly just show the obligatory. This is what typically fire seasons have been evolving over the last 25, 30 years. You can see in terms of number of acres burned, there's a marked upward trend since the early 90s, and in terms of number of fires, just a slight drop off in the number of fires relative to the number of acres burned. And you can make your own conclusions about why this is, but of course, there are a lot of different reasons. Obviously, the number one thing that comes to people's mind is climate change, but there are other factors in terms of where those fires are occurring, and the management strategies that are involved in putting those fires out, things like that. So it's not as simple as attributing it to one particular cause, but there is definitely, we're seeing larger fires and fires burning over a longer period of time than we used to see. So we can move on from there. Just quickly to go over some of the things that we will monitor as we put our outlooks together. You've seen this, the precipitation. We look at the last 90 and 30 days to get a longer term trend. And you can see here that across the southwest into southern Nevada and up into the western parts of Nevada, including the Sierras, there was a lot of precipitation there over the last 90 days. But as you start getting into the shorter time frames, you can see a lot of that occurred, especially in the Sierras, just over the last week with the thunderstorm activity they've had. But if you look at the 30 days, the moisture up into the central and southern parts of Nevada and up the Sierras, that's a pretty good indicator of the monsoon. We had a really good monsoon develop this year, a lot of moisture over a period of time, and produced a lot of rainfall. Obviously, it wasn't covering every place. There's still some areas that are somewhat dry underneath where that monsoon coverage area was. But it also brings a lot of relative humidity, higher dew points, which help mitigate some of the fire danger conditions that we would typically expect when the temperatures are in the 90s and 100s. So especially down in Southern California, as you look at this, you can see on the left, it's the calculated soil moisture from CPC, quite a big area down in Southern California of the lower percentile ranking, so essentially dry conditions, and all the way up the coast up toward Northern California. But if you look at the soil moisture from the satellite, the GRACE satellite system, you can see down in those southern deserts of California and up along the southern Sierras and into southern Nevada, you see a lot of blue where the soil moisture has been pretty good, and that's related to the monsoon that we've had. As you look up along the coastal and central regions of California and in the northern parts of Nevada, you can see a lot of dry up there. They didn't get as much precipitation, and so conditions are still pretty dry there. Keep in mind that these products are not specifically related to fire. They're more related to drought, but we can make some inferences from this information as well, coupled with other information we know about how fire reacts with the environment and how vegetation conditions can contribute to the fire problem. So this gives us some indications of where there might be some either enhancement of dry conditions that could lead to fire or some mitigation of those same fire conditions. Another thing that we're looking at is we're starting to look at the EDI, which is the Evapotranspiration Demand Drought Index. It's still relatively new in the fire community in terms of what we can get from it. But you can see in this particular example, which is the latest version, there's a lot of blue down in southern Nevada and southern California. And again, that's associated with the recent precipitation from the monsoon that they've had, and that's kind of mitigated some of those really dry conditions that might cause vegetation to be receptive to fire. But as you start in that area just above the LA basin all the way up into the northern parts of California, still very, very dry. And we're starting to see that, starting to see fires develop there as those conditions become drier up there. Now, also you have to keep in mind that this is not unusual, the fire activity we're seeing across Northern California and into Nevada. It's that time of year when we start to see the lightning from the convection associated with the monsoon surges, and we start to pick up a lot of fires, usually between mid-July and mid-August. And that's exactly what we're seeing. Interestingly enough, we're not seeing as much fire and as many acres burned as we saw last year, and certainly not as much as we saw in 2015, because conditions over the last few months haven't been as bad as they were back then. Also, some of the short-term conditions haven't been as severe as we've seen in the past in the 2015 and 2017 fire seasons. On the right is the NDVI. You saw this a moment ago. You can still see a lot of green along the Sierras, northeastern California, with some of the dry areas up in far northern California and parts of northwestern Nevada. Those are areas that we're monitoring right now. The really dark reds that you see across southern Nevada and southern California are somewhat misleading. Vegetation this time of year has not really been greened up, and this is just demonstrating that despite the rainfall, a lot of this vegetation is still not green right now. It's that time of year when it typically isn't that green, and so we're not really concerned about this because of the moisture conditions that we've seen. They're not going to really allow a lot of fire to develop there for a variety of reasons. Fine fuels are kind of out of the mix right now as their fuel moisture increases, and also we're still seeing the high humidities, which help limit the amount of fire activity that we see in that part of the region. You saw the drought. It was mentioned earlier that a lot of the drought in Nevada and California is meteorological drought, and so it doesn't have a lot of the drought conditions that you're seeing in the drought monitor. While they're important to us on the fire side, they don't weigh as heavily because we know it's more just deficits that are rather than an actual impact on a lot of the vegetation across the region. And also looking at just the climatology and the historical fire occurrence, we know that that's not an extremely critical condition for us right now. If this had been a different time of the season, then we would have put more weight into this particular product. But for now, knowing the time of year that we're in, it doesn't weigh as heavily in our estimation of the fire season as it would at other times of the year. So looking at fuel conditions, the left is 100-hour fuel moisture. This is typically something that these are dead fuels, so not live vegetation, and how they respond to the moisture and the dryness out there. And they're in the high categories, high and very high categories, but they're not at a point where we would be overly concerned. This is not unusual for this time of year. When you're getting temperatures regularly in the 100 degrees and above range, we see this kind of thing. Where we would be concerned is if we saw a lot of that red that you see in northern Nevada and up into Idaho and Oregon. If we saw that much more widespread across California and into southern parts of Nevada, that would be important to us this time of year, because that would mean that the monsoon conditions did not help mitigate some of the fire threat, and we still have a lot of area that would be primed for a lot of fire. But where we see it right now is in areas that it's very compact. It allows us to react to fire very quickly because we're not spreading resources all over the country. But we still are concerned with that Northern California area. You can barely see some pockets of red in the left image, just up in the northern parts of California. And those are areas that we expect over the next week or so will expand and get the conditions will worsen for fire. And so with the potential for lightning and then the follow-up high heat from the ridge building across the west, we expect that this area could come into play a little more forcefully over the next week to 10 days, which is not unusual for this time of year. It's a typical fire season period for them across Northern California and northwestern Nevada. This is a fire danger index that is prepared by the Missoula Fire Lab. You can see across Northern California, it has moderate conditions there, and that's mainly attributed to the rainfall that they've had over the last week or so. It has helped reduce some of the conditions by this index. But if you look into that northwestern corner of California, where they didn't get much precipitation, and the northwestern corner of Nevada, those are areas where we currently have some active fire going on, and we expect that those conditions will worsen over the next week or so. And then, of course, with the lightning potential for the next few days, we could see some fire develop in those areas as well. This is the current condition of fires, current status of the large incidents that we have across the United States. You can see not that many fires in California right now, or in Nevada. The one of most concern, as was mentioned earlier, is the Ferguson fire. That's down around Yosemite. It's 32,000 plus acres, and there's still a lot of fire out there, and we haven't been able to really contain that one, build line around it as we would normally like. It's not easy this time of year. Plus, there are a lot of implications of that particular fire that makes it fairly significant to us right now. One is it's a very high tourist area, And this is obviously having an impact on that with the park there. And of course, the smoke is hindering fire operations as well. And we're seeing similar things up at that cluster of fires in southwestern Oregon and northwestern California, where the smoke from all those fires is settling in the mornings and early afternoons, and it limits the kind of response that we can make with aerial resources during the early parts of the day. So it limits our capability. But again, this is not a lot of fire for this time of year in this region, but this is the time of year when we see a lot of lightning, and with the hot conditions and the dry fuels in parts of the region, we could see a lot more fire develop over the next few days across California and northwestern Nevada. Just to give you an example of where we are in terms of number of acres, you can see California is just about roughly 250,000 acres so far this year. The Great Basin, which is basically where Nevada sits, is 673,000 acres right now. Obviously, not all of that is in Nevada, but Nevada did have a 430,000 acre fire earlier, a few weeks ago, up in the northern parts of the state. Mainly a grass and brush fire, so it spread very rapidly in some windy conditions. So if you take out that one fire, the entire Great Basin, which includes Idaho, most of Idaho and Utah, is running right about 250,000 acres, which is pretty low for the region through this time of the year. Nationwide, you can see down the bottom, we're just over 3.5 million acres, which is not too far from what the 10-year average is to this point. And the number of fires is almost about the same, just a couple of thousand short of what the normal 10-year average would be. So it's not an exceptional fire season, but we have had a couple of fires this year. Actually, there are 5 fires this year nationwide that have burned roughly 1.5 million acres. And those were mainly grass fires. Those are really fast-moving fires that burn a lot of acreage and then go out fairly quickly. So it is not by any means an exceptional fire season for us this year, either regionally in that California-Nevada region or nationally. So over the next, our biggest concerns over the rest of the summer, obviously, are Northern California, Southern Oregon, and Northern Nevada, and particularly that northwestern Nevada region. As we get into that time of peak season for lightning activity in that part of the country, without a lot of precipitation. So the potential for fires more fires to start up there is still pretty high, at least for the next few weeks. The monsoon has mitigated much of the fire threat across the southern parts of California and the southern and central parts of Nevada. We don't expect that to change. It doesn't mean they won't have fires over the next few weeks, as there's an ebb and flow to the heat and the moisture. But they won't, at this point, we're not expecting any of the major fires or a lot of fire activity in those regions. But it's not unusual to see fires start in those parts of those states. Shorter term improvements in the central Sierras and far southern California are keeping things at bay right now. But a week or so of high temperatures and no precipitation could change that very quickly, as the precipitation that we saw in those areas wasn't enough to mitigate the threat in some of the larger fuel regimes like the forest. So once those finer fuels dry out, that could help with fire ignitions and to carry fire into the larger, drier fuels. So over the next 7 days, we'll be monitoring the whole region, but particularly Northern California, Northern Nevada, as they see an increase in the lightning activity, followed by some fairly substantially warm temperatures that could help increase the dryness and improve the environment that fire activity can occur in. And last, this is our current seasonal outlook, July, August, September. Obviously, July we're almost done with, but you can see the area that we've highlighted. It's primarily the higher terrain of California and up into northern Nevada. That's going to continue certainly into the early part of August, likely to continue into the late part of August as well, unless we get a significant precipitation event up there. But given the trends in the larger scale global circulation patterns, we're not expecting that right now. And then as we get into September, we start to get into the cooler part of the year, shorter burn periods, and cooler nights, and that helps mitigate some of the fire in the interior of the West, particularly in the grass and fuel regimes of the high deserts of the Great Basin. But we still get into, as we get into September and October, we start seeing the potential for some of those offshore wind events that typically affect the California areas, particularly the mountains. And so the fire threat will continue into September across most of California, particularly the higher elevations, as we see that a switch in the pattern from the heat to more of the offshore downslope wind events that we often see in the fall period there. So that's all I have. If there are any questions, I'll be happy to take those.
Thanks, Ed. There's one question real quick while I'm changing slides, and you might have hinted this a little bit in what you were saying at the end there, but is there less concern for coastal Southern California despite near record low precip this year?
Yeah, but Southern California is it's a Mediterranean climate, so it's very seasonal there. We get fire year round, but the really peaks in the fire season occur in the fall, or in the spring in Southern California, and then again in the fall. It doesn't mean you can't have fire during the peak of the summer months. In fact, there's a fire not far from the Santa Barbara region right now as well. But yeah, we start to peak there, a secondary peak going into September, October, when we start to get fronts that bring cold air into the interior West, and that develops a pressure gradient that starts up an offshore flow. And that offshore flow is often very dry and very warming, plus the strong winds. Any ignitions that you get there will spread quickly. So we're entering a peak of the fire season for the Southern California, all the way up to about the Central California coast as we get into September, October.
Thanks, Ed. That was the only question, and then we'll move on now to our last presentation. This is going to be by Julie Kalansky. She's the program manager with CNAP, and talking about a project I worked with her on with Southern Nevada Water Authority.
Thanks, Amanda. So this is, as Amanda said, this was a project with Southern Nevada Water Authority and Keely Brooks, who I believe might be on the call, and Jeff Johnson from Southern Nevada, and then also Dan Can and Dave Pierce. And this was a project that was funded by Southern Nevada Water Authority, and then NIDIS and the RESA program helped supplement. And I will touch on, just given our time, I'll touch a little bit more of the process and what we went through about the project, and then happy to answer questions. I'm not going to go into a lot of the results because they're very specific for Southern Nevada, and we do have a report on it that I'd be willing to share if anybody wants to get into more of those details as well. So Southern Nevada, just for a little bit of background, Southern Nevada Water Authority was created in 1991, and it supplies water to 2 million Nevadans. And they have 5 main categories or ways to think about water. So it's water supply and planning, conservation, water quality, infrastructure, and stewardship. And pay attention to, I guess, the color for conservation, water quality, and infrastructure, because that will come back and is an important part of the project and thinking about it. This is just a little bit more background. So here you see the service district. What's cut out here is Clark County, and that's important because a lot of the climate projections we looked at for Clark County as a whole, so as this whole region, but then here you can see the specific water districts that Southern Nevada Water Authority works with to supply water. And this is the Southern Nevada Water Authority is different than some other water agencies in the state that in almost all their water comes from Lake Mead and the Colorado River Basin. And so, and the U.S. Bureau of Reclamation does the long-range planning for supplies. So for Southern Nevada and thinking about climate change, at least locally, a lot of it has to do, and this is where those colors from that previous slide, the conservation, so the outdoor water demand, infrastructure, so how does climate change affect the infrastructure that they use for getting water out to their agencies, and also the efficiency of it, and then lastly, water quality. And so this is very focused on those components and thinking about climate variables rather than just the thinking about climate change and long-term supply. So this is just, there were 3 different parts of the project, and you can see here they're color-coded by blue, yellow, and red. The first one was to review the historical station data to better understand temporal and spatial variability in the region. And then I think through this, and then what I have in italics is what either group got out of it. So us working with Southern Nevada, then also too, I think through our conversations, some of the things that they got out of the project as well. And so one thing that I think came out of this is to examine the potential to enhance monitoring, particularly of temperature. And I'll show you that in the next couple of slides. And then the next step, this was based on work that Dan Can and Mary Tyree did in 2015 for the California Department of Water Resources, but it was to select the most representative climate models for Clark County. And so we took a very similar approach to the previous research, but then the climate variables were targeted more towards the goals of Southern Nevada Water Authority. And in this process, one thing I think that SNWA learned about were some of the limitations of climate models, because they do have a lot of limitations. And then us being the CNAP team, I think we learned a lot about Southern Nevada Water Authority's operations and some of the things that are most important to them in thinking about it, long-term planning. And then the last thing we did was take those the models that we determined to be most representative for Clark County and examine vulnerabilities to climate change in operations, and then also talked about what are other important variables for future consideration. So, and like I said, this is going to be focused a bit more on the process of the project. And so what we did, we had bi-weekly calls. They were about an hour. We shared the latest results. We talked about them. We had a lot of discussions about, like I said, what the climate model's limitations were and what we could learn from them, but also too what was really important and what were the important variables. We very collaboratively wrote a report on all the results, and there were a couple of iterations of that. And then we had one large agency in-person meeting. And then we're still talking about next steps with Southern Nevada Water Authority and where the report can go and the next part. So just for real quick reference for the historical climate variability, these are the 6 stations that we used. I'll note here that McCarran is the McCarran Airport in Las Vegas. And so this is a station that is used for a lot of the climate monitoring in the area, but we wanted to look at the spatial variability as well. And so the 5 other stations were stations that had at least 30 years period of record, minimal missing data, and also were continuous at the time the report started. So this is just in that first part looking at the seasonal and spatial variability. And so these are the 6 different stations. On top, what you're seeing is the maximum daily temperature, and it's on the axis here, and it's in degrees Fahrenheit. And what you're seeing is the blue line is the daily minimum temperature. And then in the gray bars is the monthly average precip from 1981 to 2010. And so this is, this confirms a lot of what we think of when we think of Southern Nevada climate. It has this dual peak in precipitation, so just the winter, January, February, and March, and then the monsoons months, July and August. And then the shoulder season, specifically spring, is very dry. Also too, you see the peaks, the high peaks in summer, and a relatively large difference between Tmax and Tmin, just a very arid climate. You also see some of the differences in locations too. Mount Charleston's on a peak, and so the elevation has quite a bit of impact on the daily total precipitation. The other thing that we looked at were long-term temperature trends, and what you're looking at on the left is maximum daily temperature, and on the right is minimum. And what you can see is that the trends for minimum temperature in both of those on this side are much longer. And so this led to discussion about how to monitor in temperature in the region, and especially to look at these differences between maximum daily temperature and minimum daily temperature. And then I'll spend a little bit more time on this, and then just given the time we have, I'll kind of summarize some of the other slides. But the evaluation process we went through was, as I mentioned, very similar to what was done with DWR, but it's first looking at 31 global climate models that have the appropriate variables saved and evaluate how they do on a global scale on principal important climate variables, so solar radiation, air temperature, atmospheric pressures, and wind. And then there was analysis done for the western US, the southwest US, to look at how different variables did in representing the statistics, so the variability and the seasonal trends in air temperature and precipitation, atmospheric pressure patterns, and ENSO. And then the last part, and this is where what was unique to working with Southern Nevada Water Authority, was what variables we looked at for their region specifically, so for Clark County, and air temperature, precipitation, and atmospheric circulation patterns. And that led to a recommendation of 6 global climate models. So this is just looking at, the blue ones are ones that are models. Here are the global climate models of various names. The squares with blues are ones that did not do as well. The ones with bright orange are ones that did better. And light orange are the ones that did okay. And then we also make some notes here on other reasons why these are good models, representative models, or to include. So these are the variables we looked at for wet winter months, wet summer months, the standard deviation and Tmax. So are they getting the variability? Are the models getting the variability right? And then the atmospheric circulation patterns that led to really wet winters, really cold winters, and really extreme heat waves. Are those representative? And then for sake of time, I'm going to actually breeze through some of the future projections, but this is just looking at, in the top, we looked at mid-century and end of century for Tmax and Tmin. And one thing to note is, the differences seasonally, that summer and fall, you're seeing a lot more increases, especially in Tmin. And then this was looking at numbers of days above different thresholds for those 6 models. And this is under no mitigation of greenhouse gases, the scenario. And then precipitation were relatively minor changes, and there's a lot of uncertainty around precipitation, which is one of the reasons you see these really, really big error bars here. So just in summary, this is the project that we worked on to look at the most representative climate models and climate in the region, and thinking about operations and how some of this information may be incorporated into Southern Nevada Water Authority operations. So I will leave it there. I'm happy to ask more or answer any questions and as a follow-up as well. So thank you.
Thanks, Julie. Real quick, while I'm changing out of here, if anyone has any questions, feel free to type, for any of the speakers, feel free to type them in there. Julie, I guess maybe you want to tell them a little bit how this process in California is related to the 4th climate assessment now, or the similar process was?
Yeah, so the similar process that went on in California was a selection of 10 climate models. And those 10 models, currently California is going under its 4th climate change assessment, and those 10 models are being incorporated into the results of the 4th assessment. And teams that are doing research on funded projects for the 4th assessment were asked to use those 10 models. The idea is that 31 models is really hard to use. It's so much data. It's a lot. And so can we make it more easily, can people more easily work with climate projections? And so it was the 10 models, and also through the 4th assessment process, there was another evaluation of how different those models were to look at 4. And so in the 4th climate assessment, between those 10 and 4 are typically what are being used and looked at for a lot of the results that are going into the 4th climate change assessment.
Thank you. I don't see any questions right now, but I'll give everyone a couple more minutes. Just want to highlight here, thank you everyone for listening today, and thank you for the great presentations by Dave, Ed, and Julie. If you want more information, feel free to contact me or go to drought.gov or the CNAP website for information. And our next webinar is scheduled for Monday, September 24th, just to continue the bi-monthly webinar series. You can find the registration for that already open on drought.gov. And as I mentioned, this webinar is recorded, so you'll probably find it even as early as tomorrow up on our YouTube channel. And then we'll also have a 2-page summary coming out soon as well. With that, since we're not answering any questions and we're almost to the top of the hour, I'll go ahead and close the webinar, but feel free to contact us if you have any more questions. Thank you, everyone.